Good day everyone and welcome to another video. In the last video we did a video on first principle and we tried to explain the various how to apply first principle in solving differentiation. So today we are going to actually be looking at faster ways to solve differentiation without much stress. And if we let's take a look at our example that we had the last time, where you have y equals to x squared, and if we apply first principle, we got that the y, the x equals to x. I don't expect a lot of students to be using first principle. I try to use it once in a while. And this easier way to do this is that when you have y raised to the power y and x is quite a function, all you simply have to do is to differentiate y, which makes it dy, and to differentiate x, you are going to have to bring whatever coefficient it has down, which is n. And then you have x, n, then remove one from it. So this is what it becomes. And then put the x. A whole lot of mathematical textbooks do not actually tell you that this is actually what really happens. When you differentiate y, what happens is that when we differentiated y, which was y with power of 1, you bring power of y down, this is 1y, and then you have 1 minus, take away 1 from this one, it becomes 1y is power of 0, and if you do y is power of 0, it makes it 1. So 1 times 1 is 1, and just put dy. So 1 dy, which is still dy. And then for this other part, if you also bring n, you then take away 1 from the one up, and then you put the x. So a lot of mathematical textbooks will not tell you that this is what actually happens. But Frank solutions takes you deep down into the root and tells you what actually happens. And then the next thing that is done is to divide through by dx. So just have the y dx equals, you divide both sides by dx comes over here, and dx becomes, you have n x is power n minus 1. So let's actually try it in this y equals to x squared. So let's apply it. So if you differentiate y, you have y, 1 will come back, and you have 1 minus 1. And then you have here 2 will come down, x, you have 2 minus 1. And here don't forget to put your dy, don't forget to put your dx. So if you do this, you're going to have 1 times y is power of 0 times dy. And you're going to have here 2 times x is power of 2 minus 1, which eventually is 1. So just put 1 times dx. So this y is power of 0 is 1 times 1 times y, you have dy equals 2x, because its power 1 is x, dx. So we divide both sides by dx. So you have dy dx equals to 2x. Some people will just go straight and do this. We just put to here minus 1 and y dy dx. Fine, it's also correct. But there are times when we begin to go higher in this course and you begin to deal with more difficult questions, when we get to the land of integration, we're going to really understand why we simply have to tell us that if we differentiate y, we're going to have the y, and if you differentiate x, we're going to have the x, and stuff like that. So generally we can say differential of y, dy, differential of x, dx, differential of 2y, 2dy, and so on. So we're going to look at much more complex differentiation, especially when you have cos. So if you have y equals cos x, okay, y equals cos x, there's a little formula you can try to use to remember. I call it the SI minus C. I just created it for myself to remember, but this is for integration. But from this, I can actually derive my differentiation on. And the simple for integration is C D minus S. What does that mean? It means when you differentiate from cos to when you differentiate cos, you get minus sign, and when you differentiate sine, you just get only cos. That's the meaning. So if you differentiate cos, you get minus sign. So just from CDS, just know that it only happens one way. Cos gives minus sign, but sine gives directly cos. So let's apply that here if you have y. So as usual, we differentiate y, it gives us dy. let's not forget. If you differentiate x, when you differentiate x, you get minus sign. So you have what? Minus sign. And then what's here? Just x, minus sign x. And then minus sign x. And remember to do your dx. So don't forget this CDS, which says cos differentiated gives minus sign. And just that sign differentiated just gives cos, not negative cos. And then you have divide both sides by divide both sides by dx. And I give it like y dx equals minus sign x. So these are one of the things which you can use sign differentiation to do. Say if you have y equals sin x, I want to differentiate. You can simply say from this that dy equals cos x dx. So if you do dy dx, you're going to get cos x. As simple as ABC. So these are the various ones, but sometimes it gets complicated, and that takes us to the three rules that are very important in solving problems regarding differentiation. And what are those three rules? I would like to show us those three rules, and I hope that we can open our minds to embrace those rules. Now, the first rule is what we call the function of function. First rule is what we call function of function. Function of function. So, when you have, I'm going to use the sign so as to make things more spicy. When you have the y equals cos 2x, let me use this as a case study. A whole lot of mathematics students will just come, because I said if you differentiate cos, you get like one of common, right? Y plus minus sine 2x. But if you do this, unfortunately, if you are, you are wrong, because when you differentiate y equals cos 2x, if you tell me that the y dx is minus sine 2x, happily, I think you have killed the examiner, or you get disappointed. So there's a way which procedure you have to follow, because cos is a function. The multiplication sign here is also another function. So because of that, is what we call it function of what? Function. Like a function inside another word, function. The multiplication function inside the cos function. So what do? We have to replace. And how do we replace? We have to make it appear like a single function. How do you do that? Imagine this 2x was not here. Imagine it was a single letter. That makes it just cos, maybe cos x, cos y, which is just a simple function. So we're going to try and create that by saying let u equals 2x. By relating 2x, we have made a function which is y equals cos u. So now we have y equals cos u and u equals 2x. These are the two functions we have. Now, I'm going to try and differentiate the both of them. Because this is a single function, this is a single function. I'm going to try and differentiate this single function. I'm trying to merge them and see how we can get our dy dx. So how do we go about that? So we have, let's take the first one, y equals cos u. So if you differentiate y, you have the y as usual, like I said. And to differentiate cos u, you have minus sine u. Remember, this is just gives us x minus sine x, and this is u. I said also remember to put your du here. And so if you divide both sides by du, you have that dy du equals minus sine u. Many viewers may not appreciate this until we get to a very trivial part in the topic. We just wish I had written dy du minus sine u. But it is true, but when it gets trivial, you need to recognize it, especially when we begin to do what we call the implicit differentiation. But for now, let's keep. I prefer to stick to it, and anybody who seems to want to follow the way I teach should stick to it. And the y du is minus sine u, and we take the second function, which is u equals 2x. If you differentiate u, you have du. Now, if you want to differentiate, you have 2 times x. So we're going to differentiate x. If you differentiate x, you have du. When you differentiate x, you have 2 times. Differentiating x, 1, so times dx. Y is differentiating x1. Don't forget, x is power 1. 1 comes to the back. X 1 minus 1, which is 1. X is power of 0. X power of 0 is 1. So we are differentiating x gives 1. So then you have du equals 2 dx. This means that du dx equals 2. So mathematically, I can begin to see a symmetry, and that symmetry is that I can, if I have my dy du, and I multiply it with my du dx, what do I have? Du cancels du, and what do I have here? Dy over dx. So this implies I can multiply my dy du and my du dx, I'm supposed to get what? The y dx. So this means that the y dx equals, what's dy du minus sine u times what's du dx 2. So we have dy dx equals minus 2 sine u. And we know that u is 2x. So we have minus 2 sine 2x. So this is the first rule. This is what we call the function of the function rule. Please, if you have any questions regarding the function of function, do it to drop so in the comment section. The second rule which we are going to be applying is what we call the product rule. And the third rule we are going to apply is the quotient rule. But for the course of today's video, I'm going to be stopping at the function rule. And subsequent video, I'm going to be using the quotient rule and the product rule. Thank you for watching today's video. Do it to subscribe and comment. Thank you.